Now we will talk about some in a previous session. We had been covered so many things regarding the sketching. Now today we will discuss about three-dimensional modeling. In technically way, we can say that it is a solid modeling, right? So for the before going to discuss the solid modeling, we have to cover some basic things of the graphics. Now there are basically four angles are there, right? First angle, second angle, third angle, fourth angle. Okay, right? Have you heard that particular things? Have you heard about that particular things about the basic things about the graphics?
Yes, sir.
Okay. Now, mostly in India, we are preferring the first angle method to create the drawing, and in the most of the European countries, like Britain and Germany, or some of the countries are referring the third angle. Now, I'm not going in detailed manner. What is the first angle, third angle, and all those things, but whatever the things we are going to create it, that is for the solid modeling. So basic things is to the imagination. We have to the power of imagination. If your imagination power is more, you can easily understand the concept regarding the solid modeling and drafting, right? So I'm taking the first angle method. Now the screen is visible. Is my screen is visible to you?
Yes, sir.
Okay. Now I'm taking the one prototype, we can say. So this is the first angle. Okay. So most likely you can observe like this. Okay. This is a first angle. Okay. So whatever the vertical plane is there, that vertical plane we count as a VP, vertical plane. And whatever the horizontal plane is there, that is called as a HP. Am I right? Okay.
Yes.
Now I will take a simple object. Let's say this is a cube, right? Imagine this is a cube. Okay. Now what I did, I'm taking the cube on the above HP. Okay, this is a horizontal plane. Am I right? This is a horizontal plane. Whatever the cube I'm taking, that is above HP. And if you observe in this right side, it is in front of VP. Am I right? This is in front of VP, right? And here it is above HP. So in order to understand, I will convert into isometric view. If you observe over here, it is in front of VP and above HP. Okay. Now this is isometric view. Why it is isometric view? Because by using this view, you can observe the three dimension. You can observe its length, right? You can observe its width. And you can observe its thickness. Okay. So if you are able to take, if you are able to see the maximum three dimension of any object, so we can call it as a solid model, right? It is called it as a three-dimensional model generally, right? Now I'm turning it, and here you can observe only two dimension, right? You can observe over here length, and you can observe over here width, right? So this two-dimensional view is called as a orthographic view, right? This two-dimensional view is also called as orthographic view. So in general, we can also call it as a sketching, right? So whatever the practical 1 and practical 2 we had been covered, that two practicals we had been covered for the sketching, that is for the orthographic view, right? So again, I'm repeating, this is orthographic view because here I'm observing two dimension, length and width, right? Now, how to create the three-dimensional object? In today's practical, we are covered the three-dimensional, okay, solid modeling. Now, to create the solid modeling, the basic thing is very important. That is, you should know the sketching. If you are not able to create the any 2D sketch, you are not able to convert it into three-dimensional. Okay. Now, see, it is very simple. See, here it is a two-dimensional view. Okay. If you are observing from the front view, let's say this is my observer. Whatever the camera you are observing, and whatever this particular image you are observing, this is your front view, right? So front view shadow is always on the HP, that is above XY. And if you are going to the top view, right? If you are going to the top view, so it is on HP, that is below XY. This is a basic first angle method, okay, that you know very well. So I'm not going to comment on all those things. So just stick to our point, that is three-dimensional view. Now I want to convert this orthographic into three-dimensional view, or I want to convert this orthographic view into isometric view. So what I will do, first of all, I will create the rectangle, okay, having certain length, having certain width, and if I rotate this first angle, if you are rotate this particular first angle view, now you are getting the isometric view. Let's see, you are having the three-dimensional view. That means I am adding the material from the sketch. By using the sketch, I am adding certain material in z-axis. If you are add this material into z-axis, that is called as a extrude. This command is called as a extrude. That means you are adding some material into the third axis, right? So before going to discuss all those things, we can go to the practical session. Whatever the example I told you, so for the simple example, I will create the 3D model. So I will use the software for that. So for the software, I go to the, I will open the required particular software, that is Pro Engineering. Okay. So for that purpose, I will go over here. Okay. So I will share the screen to on the software. So this is a PTC company software. Okay. That we had been discussed. So here, now the point is very important. Okay. Now, what I will do, I open the software over here. Okay. Now I want to open the particular window to create the software. So for that particular purpose, I will open new. Now here there are lots of options in front of you. First one is sketch. The extension of sketch is always .sec, that had been covered in the first two session already. Now I want to create the solid object. That means I want to create the part. So for that particular purpose, I will go to the part. Okay. Now here there is one option is there. Use default template. Now why this is use default template? So in a metric, there are lots of dimension is available. You can you can take the centimeter, you can take the millimeter, you can take the so many dimensions. To select that dimension, what I will do, I will untick over here and I will press OK. Now I want to take all the dimension in mm. So please listen carefully. Whenever you are creating any new solid object, that time you have to do these particular things. I will repeat once again. I will go to the file, new, part. Now I want the particular dimensions in metric, that is in mm. So I will untick over here. I will press OK and I will take mm of part of solid. That is all, whatever the dimension I will take, that is all the dimension in mm. Okay. Once I press OK over here, it will take some time and it will show you the different views, right? Like front view, top view, right view. Okay. So whatever the things I explain you for the solid object, in the direction of front view, I will observe as a rectangle. So I will select the front view and I will go to the, here there is one option is there, sketch. What I told you, that if you want to create any solid object, what is the basic condition of the solid object? You have to able its sketch. If you are not able to create the sketch, you are not able to do the 3D object. As simple as that. Now to create the 3D that particular 3D object, what I will do, I will go to the sketch command. Okay. So whatever the practical we had been covered regarding the simple sketch exercise, that you can understand that one. So I will go to the sketch. I will select the front view. Then I will go to the sketch. Now the first step, you have to create the axis. Very important. By means of axis, if you give the axis, you know the orientation, or you can go if you are locate the axis, That means you can have the position of origin, and with respect to origin, you can measure any dimension, as simple as that. So once you select the dimension, go to the views, whatever the front view, top view, whatever the view, in which direction you are observing your image. According to that, you can select your view. That is, I'm observing my particular image in front view. That's why I select the front view. Then I go to the sketch and I given the axis. Now see, I have the rectangle. So whatever the dimension is there, I will simply create the rectangle like this, right? And I will go to the back command. I will give the particular dimension that you know very well. Let's say example that is a 200 by 200 of cube is there. I will press 200. So all dimension in mm, huh? Because I've taken the dimension mm solid, right? So here 200 mm is there. That is 20 centimeters. Now again, I will go to the enter 200, and I will again here taking the dimension as 200. Okay. Now this is a sketch. Now this is the your orthographic view. Now I want to convert it into isometric view. That means I want to convert this sketch into 3-dimension. So what I will do, I will press the center button of your mouse and I will tilt the geometry like this. Are you observing? So this is your isometric view, but it is not having certain direction. That means it is not having certain depth. That length is 200, width is 200, that is okay. But I want to add some thickness. If you extrude the particular material in certain direction, that means you are converting 2-dimension into 3-dimension. So for that particular purpose, here is one command is there, that is done. I will press the done and I will go to here command, that is extrude. That is nothing but to add the material. If I press the extrude command over here, now see it is extrude. Now here there are certain time particular constraint is given over here. First constraint is your you want to extrude as a solid. Obviously, if you want to extrude as a surface, then you can extrude as a surface. Now here there are 3 constraints is there. Number 1, that means extrude from the sketch plane. My sketch plane is front view by a specific depth. Now I want to extrude in one direction only. Okay. Now if I want to extrude in both direction, now if I want to extrude in both direction, I will press the second option over here, extrude in both direction. Let's see, it is extruded into the both direction. See, first option is extrude in one direction. Now I want to extrude in particular right side. That is okay. If I want to extrude only in the left side, I will reverse the direction like this. Okay. Just reverse the direction, right to left, left to right. So simple. Okay. Now I want to extrude in both direction. So go to the second option. And whatever the depth is there, let's say depth is 50. So you don't have to do any calculation. Software is able to do all the calculation. Okay, you don't worry about the calculation. Whatever the entire depth you require, you just have to write down the depth. What the software will do, software will automatically divide this 50 by 2 and it will be extrude 25 in left direction, 25 in right direction. Okay, I'm again repeating, whatever the depth you require, total depth, that only you have to press, you have to type over here. You don't need to divide, you don't need to do any calculation. Okay, software, there is algorithm is there, software are able to do the particular calculations. Okay, you don't worry about it. And after once it is over, okay, you press enter and there is one spec is given, preview. That means before you want to finalize it, you can press the geometry. Okay, so see, this is my 3D object. If you are satisfied with your 3D object, then you have to press over here, done. Okay, now there is one model tree is created. Once you have created the object, whatever the instruction you are giving, extrude, sketch and all those things, here is a tree. You know the tree having different branches, right? So like that way, it is one kind of model. Once you have created the model in different way, the models had been created and that is going to be observed in your model tree. Now I want to add, now whatever the particular object is had been created, now I want to do some changes in the sketch. Now I want to edit my dimension. And this is one of the advantages of your CAD. What is CAD? That is nothing but your whatever the geometric model is there, sketch, surface model, 3D model, wireframe, your solid modeling, wireframe modeling. You have to create the object, and again you can modify it easily. That's why it is called as a computer-aided design. And under the computer-aided design, there are lots of software is available. One of the software is Pro Engineer, and under that Pro Engineer, we are doing the solid modeling. Now I want to edit particular dimensions. Okay, so for what I will do, I will directly go to the tree. Just observe the tree. If you want to edit the dimension, what I will do, there is one plus button is there. You can go to the plus mark over here. There is sketch is there. Now I will go to the sketch. I will use the right command, and there is one option is there, edit definition. Yes, there is one option is there, edit definition. Go to the edit definition. Now I want the particular 300 by 300. Don't worry. You just edit the dimension 300. You can give the dimension. Let's say I want 300 by 50. So I will press 300 by 50 like this. Okay, and you have to press over here. See, so whatever the square is there, that is converted into the rectangle. So simple. That means you can edit whatever the things you require, you can edit. Now let's, okay, now I want to, whatever the third material I'm adding in the particular geometry, let's say in Z direction, I want to edit this particular dimension. So simple, go to the extrude. Here is one option is there, edit definition. And you can do the here 100, enter. If you want the more than that, let's say 1000, you can press. That is in mm, huh? That means 100 centimeter. Enter. Now the screen, whatever the dimension, due to the more dimension, it is expand, and you are not able to see the proper dimension. So there is one option is there, refit. There is one option is there, refit. You can press over here. So whatever the screen is there, it is again, you can have your original screen. So see, this is a 3-dimensional object, right? Is it fine? Is it fine? Is it fine to all of you? Hmm? Okay.
Yes,
Now
sir.
I want to add some material over here. Okay, so what I will do,
Yes, sir.
here you are doing the geometry. From which plane you want to create the geometry, select that particular surface first of all. Now what I will do, I will tell you first of all, I want to create the hole over here. And I want to add some cylinder material over here. At the left side, I want to create the hole. And at the right side, I want to create some kind of adding the material. Okay, I want to add the material. So what I will do, I will select the upper surface, this surface, and I will go to the sketch. Okay, sketch. Fine. Now here there is a line is there, but I'm not able to see this line properly. This vertical line, this horizontal line. Okay, so for that purpose, I will give some references to that. So for that purpose, there is one option is there, sketch. In the sketch, there is one option is there, references. Okay, so I will go to the sketch, references, and I will give this edge as a reference. Now see, you can observe this line, dotted line properly. I want to give this as a reference. You can give the reference. I want to give this line as a reference. So you can give the reference like this. See, now you can observe this line. Previously, you are not able to observe the line because reference is not given over there. Now, if once you given the reference, you can easily calculate the point. You can easily calculate this corner point. You can easily calculate this horizontal and vertical lines and so much things you can determine. Okay. Now, I want to create the particular hole, so I will create the circle. Okay, so sketch is very important. Okay, so I will create the circle of 90. Okay, and I will tilt the particular things. That means I'm converting orthographic into isometrics. Okay, now I will go to the done command. Okay, now the extrude is nothing but to add the material. Okay, if you see the preview over here, see this is one kind of cylinder structure you are observing over here, right? Okay, but I want to remove the material. I want to make the hole. So what I will do, I will reverse the direction. Okay. And here there is one option is there, remove material. There is one option is there, that is removal of material. So I will press the removal of material and I will see the preview. See, the hole is created. So simple. Okay, done. Now I don't want the hole throughout the material. I want this. I just want the some kind of we can say the particular. I want the. I don't want the to create the hole in the entire depth. I just want to create the hole at certain depth only. So again here extrude to edit definition. So you can give the depth. You can shift the particular depth as per your will, or you can give the dimension. You can place the command over here. Done. Now see, there is no entire hole is created. Now, if you are not able to understand it, there is one option is there, that is wireframe. So you can go to the wireframe, okay, and you can observe these things like this. You can press right button and you can observe the particular things. See, the hole is not in a particular depth. Let's see. Now, again, you want to convert wireframe into solid. There is again one option is there, so shading. Go to the shading. So you can observe this. Okay. Now again, I want to create some material. I want to create some cylinder over here. So again, I will go to the sketch. We'll select this surface. Selection of surface is very important. You can select the surface. You can select the plane. Okay. And I will create some. Let's say I want to create some rectangular kind of material. I want to add some rectangular kind of material. Okay. And I will convert into isometric. Once your geometry is over, you have to convert into sketching into that particular orthographic into isometric. If you are able to do this, once your geometry is created, sketching is created, convert, then shift your geometry from orthographic to isometric. Why it is important? By means of that, your visualization is improved. Okay, and it's all about your visualization. How much your visualization power is more, you are very handy in your sketching and modeling, and you can handling in the particular software. So once your sketching is over, you just convert this sketching into a particular orthographic into isometric. Okay, and I will done over here, and I will add some material over here, whatever the depth. If you want in a both direction, you can use this. If you want in only one direction, use this one. If you want to give the dimension as 500, you can do it. You can see the preview. You can see solid object is created. So simple. Okay. Now I want to make, see, particular edges are very sharp over here. I want to use some solid round. So there is one command is there, round. So press the round command and you can press the particular edges. You can press edges like this over here. So I want to give some round because it is very sharp edges. If it is a sharp edges is there, there may be the possibility of stress concentration, right? So in order to avoid the stress concentration, we are always giving the some fillet to the material. We are giving the round to the material. The basic intention is to avoid the stress concentration. So for that purpose, I will give some round over here and I will give the dimension 20. Now see, whatever the your sharp edges is there, that is been there, removed like this. See, okay. If you want to add the dimension, again go to the model tree, go to the edit definition, and if you want the 25, you can do the 25 like this. Okay. You can go to the refit. The object is created. So once you practice more and more, the particular solid modeling is very easy. So it is a link. This is like a chain. If you are able to understand the sketch, then and only then you are able to do the modeling. And if you understand the modeling, then and only then you can create the assembly. This is one kind of chain. So whatever the things is there is going in the lecture, that is very important. Okay. So I want to save the file. I can go to the file, save. In the desktop, I will save the particular file. I will create a new folder, that is modeling, or we can say this solid modeling. Okay, and I will save this as a PRT. So PRT is very important, the extension. Okay, for sketching extension is .sec. Whenever you are creating any computer file, digital file, every file having certain extension is just like a pin code. If I want to give the letter to anyone, the pin code is very important. Am I right? If there is no pin code, you are not able to give the letter to anybody. Like simple like that. This is one kind of pin code. Every digital file that is a computer file is having certain extension. If you are creating the file in Word, it is having extension like DOC. If you want to create the Excel file, the extension is .xlc. If you want to create any sketch, the extension is .sec. And if you want to create if you want to save any modeling file, the extension is like .prt. Okay, as simple as that. You can open over here. You can save, and if you want to open, you can again go to the open, and you can see the preview from this. Before going to open the file, you can see the preview. See, I am rotating the figure. Okay. The file is created. Okay. Any doubt up to this?
No, sir.
Yes.
No, sir.
Okay. Okay. Fine. So after that, so we can continue the. This is a solid modeling. This is a very simple example, and from the next session we can directly start with the assembly. So in the assembly, you can create the different kinds of mechanical component solid modeling, like a nut, screw, bolt, spring. Then there are different surfaces there. Sheet metal operations are there. For the sheet metal operation, whatever the sheet materials are there, that we have to create is solid modeling. It is comes under the category of surface modeling, that we can also do it. Is it fine? Is it fine?
Yes, sir.
So for the, I will share the screen and I will show you here. This is one kind of assembly is there, which is very simple. See, this is isometric view. This is isometric view. Whatever this view is there, assembly view, this is isometric view, which is having the different parts. So how many parts are there? Bottom plate, like this kind of parts are there, bushing, guide bush, and all those things. So this is orthographic view. That is a sketch, we can say. And this is your isometric view. We call it as a 3D view. But in the 3D view, there are different parts are assembled to each other. That's why technically it's a 3D view, but more technically we call it as an assembly view. Okay, so that assembly view we have to create in the next session. Is it fine? So next session we can directly start with the simple
Yes,
assembly. That is a pillar support. This is one kind of pillar. See, you can observe the 4 pillars are there. That is assembled by the guiding pin and the base plate and the top plate. So this is one kind of example of your pillar support assembly. Okay, that we can discuss next lecture.